good evening to all. So this is Sillamar from SNS College of Technology and Department of Computer Science Engineering. So now I am going to tell about process synchronization operating system and the classic problem of synchronization. So what is the classic problem of synchronization means? So in the classical problem synchronization we have three types. One is the bounded buffer problem, and the readers and writers problem, and the dining philosopher problem. So first one, the bounded buffer problem. So in our bounded buffer problem, the producer and consumer process share the following data structures like mutex and 1 and mtn and semaphore full equal to 0. So we have a structure of this procedure process. So first we have to do the which item can be produced next. So wait state is empty and wait is a mutex. So add next producer to the buffer. So signal mutex and signal full. So while it condition true, it will move to the next process. Okay. So the structure of the consumer process, the same thing, the wait full and wait mutex. So remove an item from the buffer to next consumed, so that the signal mutex, the signal empty, the condition is true means then the consumer problem is consumer part of the process is executed. So note the symmetry between the producer and the consumer. So we can interpret this code as the producer producing full buffers for the consumer, or as the consumer producing empty buffers for the producer. So the readers writers problem means, suppose that a database is to be shared among several concurrent processes. Some of these processes may want only to read the database, so whereas others may want to update, that is to read and write the database. So we distinguish between these two types of process by referring to the former as a readers and to the latter as writers. So obviously if two readers access these shared data simultaneously, so no adverse effect will result. So however, if a writer and some other process, either a reader or a writer access the database simultaneously, choice may ensues to ensure that these difficulties do not arise. So we record that the writers have exclusive access to the shared database while writing the database. The synchronization problem is referred to as the readers writers problems. So the readers writers problem has several variants, so all involving priorities. The simplest one is referred to as the first readers writers problem. So requires that no readers be kept waiting. So unless a writer has already obtained permission to use the shared object. So in other words, so no reader should wait for other readers to finish simply because a writer is waiting. So second readers writers problem requires that, so once a writer is ready, that writers perform its write as soon as possible. In other words, if a writer is waiting to access the object, so no new readers may start reading. So a solution to either a problem may result in a starvation. So in the first case, so writers may starve, in the second case and the readers may starve. So in this solution, the first readers writers problem, the readers process share the following data structures like a semaphore reader and write mode is equal to 1, semaphore mutex equal to 1, and in the read count equal to 0. So we have a structure of the writer process. So we have to wait for reader writer mutex. So writing is a perform, signal write signal for reader writer mute, and then while the condition is true, it will be executed. So the structure of the reader process will execute the reading the performance of wait and read count. So if the count equal to 0 means signal is muted, and then it is a condition is true. So once the condition is false, the after the reader, so the condition is incremented plus count plus plus, the other state is incremented. So the reader writers problem and its solution have been generalized to provide a reader and writer locks on some systems. So acquiring a reader and a writer lock requires specifying the mode of the clock. So either read or write access when it is process wishes only to read shared data. So it requires the reader and a writer lock in a read mode. A process wishing to modify the shared data, so must requires the lock in a write mode, and multiple processes are permitted to concurrently occur. So a reader and writer lock in read mode, so but only one process may acquire the lock for writing. So as exclusive access is acquired for writers. So in applications where it is easy to identify which process only read shared data and which process only write shared data. So in applications that have more reader and than writers, this is because reader and writer lock looks generally require more overhead to establish than semaphores or mutual exclusion locks Then increased concurrency of allowing multiple readers compensate for the overgate and involved in setting up the reader and writer lock. So this is dynamic philosophers problem, the situation of the dynamic philosophers. So we the shared data semaphore chopsticks. So allow at most 4 philosophers to be sitting simultaneously at the table. So allows the philosophers to pick up a chopstick, and only the both chopsticks are available. So to this she must pick them up in a critical section. So use an asymmetric solution, that is an odd numbered, and the philosopher picks up first her left chopstick and then her right chopstick, whereas an even numbered philosopher picks up her right chopstick and then her left chopsticks. A deadlock free solution has not necessarily eliminate the possibility of starvations. Thank you.